Hello, and welcome to my garage. In this video, I'll be giving an overview of how I made a microphone inspired by the one used by Bob Barker on The Price is Right. I'll be touching on selecting the circuit design and components, creating the schematic and laying out the circuit board, actually cutting the circuit board on a CNC mill that's also here in my garage, and finally I'll solder everything together and assemble it. Then we'll test it out and see how it sounds. If that sounds interesting to you, then please stay tuned and check it out. You may notice that I'm not actually using the mic right now to record this audio, and that's because it has a couple of issues that we'll go over later. But on the whole, we're going to find out that this project was a success, and I can already imagine some fun uses for the microphone. Okay, so that's enough fluff. Let's get on to the steps involved. The first thing we need to do is choose the circuit topology or the overall design. And for this, I'm going to be using a design guide provided by Texas Instruments, and I'll be adapting it to my requirements. Once I go through some calculations to adjust the design to my needs and I know the component values, I go ahead and order what I need, and then it's time to get to laying it out in a schematic. All the components get laid out in symbolic form and the connections between them are made. During this step, the components are also assigned their values and given a footprint. The footprint represents the physical space that this component is going to take up on the circuit board. I like to take my time to organize it nicely and make sure that everything's legible. While this isn't strictly necessary, it will be helpful in future designs. For instance, I can reuse this schematic and just change a few values. It also helps it to be more legible, and I'll use that during assembly so that I don't mix up any values. With the schematic complete, it's time to move on to the physical board layout. I start by drawing the outline of the board so that I know the constraints that I have to work within. The next step has some logic to it, but also some art. Because arranging the footprints and making the connection between them has no definite solution, I try out a few different things before settling on something that I think works. Well, it mostly works, and we'll find out more about that here in just a minute. Once the board layout is done, I use a tool called PCB to G-code, and that takes the output from KiCad and it turns it into something called G-code, which is the instructions that the mill will understand in order to etch out the paths for the circuit board. To actually send the G-code to the machine, I use another piece of software called IO Sender. One feature I really like about this piece of software is its comprehensive probing. No, not that kind of probing. Because this is such a fine etching process, it's necessary to create a height map of this copper-plated fiberglass. IO Sender can take the height map information and apply it to the G-code before sending it to the mill. Without the probing process, we get cuts that are either too deep in some places, or maybe in some places they don't cut at all. I had this experience in the past and it took me quite some time to figure out, but now I have everything running smoothly. The milling process involves 3 different tools. In one step, I etch out the pathways or the tracks and the footprints for the various components. In another step, we need to drill holes because we have connections on both sides of the board. And the final tool is used for the edge cut and makes a nice clean edge on the board. Because this is a 2-sided operation, there are 2 pins here on the milling table, and those make sure that everything stays aligned when I flip the board over. We repeat the process from the front side on the back, and eventually have a completed board in hand. With the finished board in hand, we can now solder on the components. For this particular design, I'll need 2 electrolytic capacitors, 11 resistors, 1 ceramic capacitor, 3 tantalum capacitors, 1 Zener diode, 1 transistor, 1 amplifier, and 1 microphone capsule. I realized while editing this that I didn't actually get a very good camera angle of this, especially because I'm right-handed and I put the camera on that side. I'm mostly just blocking the view. I'll keep this in mind for a future video and try to get a better angle. At least I can show my chiropractor why my neck hurts so much. After spending a couple hours looking really closely at boards, Sometimes I do have a bit of a sore neck. At this point in the process, I hadn't fully figured out how I was going to attach the rod to the XLR connector, but I still wanted to get a sense of how the microphone sounded or if the circuit actually worked. I attached some small leads to the microphone capsule, and I managed to get the entire thing to fit inside the connector. Maybe that's another idea, a very tiny mic that's just the connector itself. As we see, my first sound test doesn't produce any sound actually, and at first I was disappointed, but then I quickly realized my mistake. I reversed a couple of the pads on the XLR connector in the board layout. While this isn't ideal because I want to be able to just use a standard XLR cable, I can work around the issue by creating a custom cable for this version of the project. In all the excitement and frustration, I forgot to record making the custom cable, but suffice it to say I ended up with one anyway. Sure enough, once I use the cable, I get some sound from the microphone. Hello. Testing. All right, I think it works. For the final assembly, I really didn't have any great idea, but I did find a couple O-rings that fit nice and snugly around the brass rod. I kind of crudely trimmed these so that I could shove them into the end of the XLR connector, and it makes a kind of stable, for what it is, it's a surprisingly stable connection. My wife bought me this novelty microphone in a gas station one time when we were on vacation. She thought it was kind of funny. I like to have kind of novel tiny mics, so I also thought it was funny. Unfortunately, it's not a great quality or good sounding microphone, which I guess you don't expect from a gas station microphone. So I'm going to be using it as a donor for this project here. I went ahead and cut the bottom off and took the capsule and wiring out, and I used the same O-ring trick. I cut it out and I shoved it into this body, and it fits okay. After soldering the capsule on and putting the windscreen, shoving all the electronics back in, it's time for a final test. All right, here we have the Bob Barker Mic V1. I'm pretty happy with how it turned out. I think it looks really good, and it mostly sounds okay. It does have a problem. I've been playing around with it a little bit already, and it has a bit of noise. Right now I have the gain on my audio interface turned pretty low, and that seems to help. And I think something about how I hold it too. It's got some grounding issues, so sometimes there's a buzz if I touch the wrong place. But this wasn't intended as a, robust, finalized product. It's kind of just a novelty gag thing right now. But maybe, if it... I do want to make a version 2 where I fix a couple of the issues, like the non-standard cable, and ground it a little bit better, figure out if I can solve this occasional humming issue that I get. I'd also like it to be telescoping. The original Bob Barker microphone could extend in length, and I wanted to kind of do that with this microphone, but it was really difficult. I have these rods that fit inside of each other and can be made to be telescoping, but it's a lot harder. There's a few technical difficulties that I've had, and we'll go over that in another video if I ever actually solve those problems. Until then, if you're interested in my eclectic mix of content, I have a couple more making microphone videos and other electronics projects, and I also have a couple skits like fake commercials and song parodies where this little guy's surely going to make an appearance. So if that sounds interesting to you and you want to see what I got going on in my garage, then please like and subscribe to stay up to date. Bob Barker! Come on down! Oh, I think plenty of headroom. That really hurt my throat.